Hello friends, dear learners and my dear student. First of all, I take an opportunity to welcome you at my M.Sc second Analytical Chemistry class. I am Dr. S.R. Labhade, working as Associate Professor in Chemistry at the KTHM College, Nasik. Student, in previous lecture we discussed the polarography and hydrodynamic voltammetry and their applications in analytical chemistry. We know that polarography is a linear scan voltammetric method of qualitative and quantitative analysis performed in a quiescent analyte solution using polarized dropping mercury electrode as a working electrode and pool of mercury as a counter electrode. In addition to this, we discussed the derivative technique of polarography, that is a hydrodynamic voltammetry, which is performed in an analyte solution which is continuously in motion by using a stationary working electrode. We also know that hydrodynamic voltammetry is more superior than polarography. Student, in today's lecture we discuss another voltammetric method of quantitative and qualitative analysis. This voltammetric method have a lowest detection limit and it is more sensitive than polarographic and hydrodynamic voltammetry. This voltammetric method is performed in a two steps of analysis. First step is a concentration step and second step is called as stripping step. Therefore, the technique is called as stripping voltammetry. Stripping voltammetry is also called as a stripping chronoamperometry. In this technique, chrono means a time, that is a Latin word, and amperometry, the voltammetry by measuring current, and stripping means to remove or redissolve. Therefore, stripping voltammetry is a method of voltammetry, method of qualitative and quantitative analysis via stripping the pre-deposited analyte from the working electrode. Therefore, in stripping voltammetry, the potential at which the analyte is removed from the working electrode is the identity of the material, and the current during the stripping operation is directly proportional to concentration of analyte. Therefore, both qualitative and quantitative analysis is done by means of stripping voltammetry. During stripping step, the potential at which analyte is stripped out from working electrode is its identity. Why? The magnitude of current during stripping step is directly proportional to the concentration of analyte stripped from working electrode. Therefore, in stripping voltammetry, the potential at which analyte is resolved into a solution, that potential is the identity of the material, and during stripping step, whatever the magnitude of current thus obtained is related with the concentration or the amount of material which is removed from the working electrode. Therefore, both qualitative and quantitative analysis is done in stripping voltammetry, and it has a lowest detection limit up to 10⁻⁻10 moles. Therefore, concentration up to 10⁻⁻4 mole determined by the stripping voltammetry. This is applicable to those analyte which are reversibly oxidized and reduced at working electrode. Therefore, stripping voltammetry is performed in a two-step. First step is called as pre-concentration step, and second step is called as a stripping step. Now we discuss the working electrode used in a stripping voltammetry. Students, stripping voltammetry is performed in a two steps of operation, and these two steps, first step in this operation is called as a concentration step. Concentration step in which the pre-deposition of the analyte is carried out onto the working electrode. In concentration step, the analyte is electrolytically deposited onto the working electrode, generally made up of mercury. This electrode deposition process is carried out in a major time. The electrode deposition process is carried out in a accurate major time since This time should be constant for sample as well as analyte. This time must be same for determination of standard and sample during measurement, as it is a comparative technique. Measurement, because all voltammetry are comparative method. Of analysis. In a concentration step, analyte is electrolytically deposited onto the working electrode. During this, analyte may be oxidized or deposited onto the working electrode, or it may be deposited by reduction process. Therefore, pre-concentration may be carried out either by oxidation or by reduction of the analyte. Therefore, analyte is deposited onto the working electrode in a measured time. Time should be accurately measured, and it is kept constant for determination of standard solution of analyte and determination of sample solution of analyte, because it is a comparative method of analysis. The second step of stripping voltammetry, that is called as redissolution of sample, called as stripping step. In stripping step, analyte is redissolved into solution. In stripping step, the pre-concentrated analyte is redissolved back to the sample solution via electrolysis process. That means initially electrolysis process is used to deposit the analyte. Now the electrolysis process is used to redissolve the analyte. Therefore, in stripping step, pre-concentrated analyte is redissolved back into the sample solution via electrolysis process. During stripping step, the potential at which analyte strips back into the solution, at which analyte strip back into solution, is its identity, while the current observed is directly proportional to the amount of material, Therefore, here analyte is redissolved back to the analyte solution. During this, potential scan is in opposite direction, but this potential is scanned linearly from the reduction potential to oxidation potential, or oxidation potential to reduction potential. Therefore, here the potential sweep program in a second step, that is a linear, the potential scan is linear during stripping step. During stripping step. Therefore, we may say that stripping voltammetry may be a linear scan voltammetry. But here, the concentration step is carried out by stirring the solution, and stripping step is carried out when solution is quiescent. The concentration step is carried out by stirring the solution, stirring the sample solution, while stripping step is carried out in a quiescent analyte solution. Therefore, here potential scan is linear. Stripping is carried out in a quiescent analyte solution. That is nothing but it is similar to a polarographic analysis, linear scan voltammetry. Therefore, it is a one type of linear scan voltammetry. Students, now discuss the working electrode in stripping voltammetry. The working electrode in stripping voltammetry are made up of a mercury. Generally, a mercury working electrodes are preferred in a hydrodynamic voltammetry. Generally, a hanging mercury drop electrode and second mercury thin film electrode are used in stripping voltammetry. Hanging mercury drop electrode means a single drop of mercury is hanged at the tip of the capillary. That mercury drop is made stationary, which is hanged into the analyte solution. Mercury thin film electrode, in which a thin layer of mercury is obtained on a glossy carbon, therefore it is called as mercury thin film electrode. Graphite or carbon is a conducting electrode, and therefore here we may use either hanging mercury drop electrode or a mercury thin film electrode for voltammetric analysis. Generally, mercury is preferred for analysis because it is available in pure form. It easily forms the amalgam with many metal. Fresh electrode can be easily obtained simply by obtaining new drop, simply by obtaining new HG drop, and more important thing is that many metal shows reverse the metal undergo a reversible oxidation and reduction at working electrode, reduction at Hg surface, and therefore here the mercury electrode is preferred because it forms an amalgam with many metals. That means metal is deposited onto the mercury electrode and it is back redissolved into the analyte solution. Fresh electrode can be easily obtained simply by generating a new drop on the tip of the capillary. Many metal ions or analyte ions undergo reversible oxidation or reduction at working electrode, means at dropping mercury electrode, at this mercury electrode, and therefore mercury is preferred in a voltammetric analysis, and in stripping voltammetry also a mercury electrode is preferred. In addition to this, many metal electrodes, stationary electrodes are also preferred in the voltammetric analysis, or this a Now we discuss the construction of hanging mercury drop electrode and mercury thin film electrode. The hanging mercury drop electrode is constructed simply by generating a drop of mercury on the surface of on the tip of the capillary, therefore which is hanged into the analyte solution. This is a analyte solution. Here this is a Hg drop, that is a site of reaction, and here generally solution is stirred, therefore it is kept over a magnetic stirrer. This is stirring part, and here this electrode is either applied negative potential when it acts as a cathode, or a positive potential when it acts as a anode. Therefore here both cathode as well as anode, both functions are performed by this working electrode. This is the construction of hanging mercury drop electrode. And second type of electrode is mercury thin film electrode. In this case there is a glossy carbon rod, or you may say a graphite rod. Graphite or a glossy carbon rod which is held in an analyte solution. In that analyte solution, a Hg nitrate, that is mercury nitrate, is added, and here this graphite applied either negative or positive potential depending upon the type of reaction. This is the analyte solution in which mercury drop is this is the analyte solution in which mercury nitrate is added. Here during pre-deposition step, or electrodeposition step, this Hg is first reduced to Hg, and thin layer of Hg is obtained, over the glossy carbon. Therefore, here a thin layer of Hg is obtained over this, that is a mercury thin layer, and mercury thin film is generated on the tip of the surface of this capillary, on the surface of this graphite rod, which gives the more surface area. Therefore, here another advantage is that we can rotate this glossy carbon electrode simultaneously when this stirring is carried out. That means stirring can be carried out by using this electrode, but stirring is not possible with this electrode. This is the construction about the hanging mercury drop electrode and mercury thin film electrode. Both electrodes are utilized in hydrodynamic voltammetry. But here this electrode gives the more accurate result than this hanging mercury drop electrode. The mercury thin film electrode, the mercury thin film electrode is prepared by simultaneously plating a thin film of Hg on a glossy carbon. Here Hg second nitrate is added in sample solution and during deposition process, first upon the reduction of Hg second is carried out on the surface of Hg second is carried out on the surface of carbon rod, then surface of carbon rod and thin film and mercury thin film electrode is constructed. This electrode gives the uniform surface area over this graphite rod. Surface area provided by this electrode is more than the dropping mercury electrode. Therefore, the rate of reaction found to be more using this thin film electrode. In addition to this, the sharp peaks are obtained on a stripping voltammogram when here a mercury thin film electrode is used as a working electrode. But here hanging mercury drop electrode gives more reproducible result when concentration of analyte is more. This is the advantages of the hanging mercury drop electrode and the mercury thin film electrode. Therefore, mercury thin film electrode gives more sharp peaks on voltammogram because the redissolving step of analyte is carried out with low diffusion path, because diffusion process that is taking place on the surface of this mercury drop takes a very low time compared to the analyte which is deposited inside the mercury drop of hanging mercury drop electrode. Therefore, here this electrode provides more path for redissolution process, while this electrode provides a less path for redissolution process. Redissolution process. And due to this, sharp peaks are obtained on the voltammogram where mercury film electrode is used. In addition to this, mercury thin film electrode gives more surface area for analysis. And here, hanging mercury drop electrode gives more reproducible results with higher concentration of analyte. That means here the capacity of this thin film mercury electrode is low to deposit the metal ion on its surface. Therefore, hanging mercury drop gives the more reproducible result in a analyte solution having more concentration. Student, this is about the construction and working of the working electrode used in stripping voltammetry. Generally, hanging mercury drop electrode and mercury thin film electrode, both are made up of mercury, are used in. Student, with this discussion, you can find out the answers of following questions. Question number 1. What is stripping voltammetry? What is stripping voltammetry? Give the principle of stripping voltammetry. Give the principle, analytical principle. Give the analytical principle of stripping voltammetry. What are the steps involved? What are the steps involved in stripping voltammetry? Next question, give the construction and working of hanging mercury drop electrode and mercury thin film electrode for stripping voltammetry. Explain the advantages of mercury thin film electrode over hanging mercury drop electrode. Student, with our today's discussion, you can find out the answers of this question. With this, we stop here. Thanks for joining me. Wish you all the best. Keep learning. Happy learning.